Have you ever wondered how a computer runs dozens of programs at once on just one CPU, a single network card, and limited RAM, all sharing the same hardware? This is made possible by a brilliant abstraction known as a process. This abstraction has defined how modern computers run programs, from your laptop to massive web servers. In this video, we'll dive into how this brilliant concept works. To fully understand its benefits, it is useful to step back and examine how programs were executed in earlier computing systems. In the 1950s, computers were large machines without screens and lacked the capability for multitasking. They could execute only one job at a time in sequential order. On systems such as the IBM 1401, operators submitted jobs into a batch queue, which the computer processed one after another. The drawback of these early systems was that one job had to wait for another to finish, even if the active job wasn't fully using the processor. By the 1960s and 1970s, as computers became more powerful, the need to improve processor utilization gave rise to the concept of multi-programming, a technique that allows multiple programs to reside in memory and execute concurrently. In this model, when one program is waiting for an I/O operation, such as sending data to a printer, another program can utilize the CPU, thereby ensuring that computing resources are not left idle. However, this approach came with a challenge. How do we keep track of each program's execution state, resources, and progress, especially when the CPU switches rapidly between them? To solve this, operating system designers introduced the process, a way to represent a program in execution. Let's take, for example, a simple program that downloads a file from the internet. To run, this program must be represented as a process. The process comprises of several interrelated components that allow the program to run successfully within the computer system. The program code. This is the set of instructions that the CPU executes. In the example of downloading a file, the program code contains the logic required to establish a network connection, request the file from a server, and write the received data to storage. Handles to hardware. These allow the program to have access to specific hardware resources such as the network interface card and hard drive. The network card to fetch the file for the web and the hard drive to store it. At the same time, the operating system manages the process by maintaining metadata about it, such as its unique ID, current state, and the amount of CPU time or memory it is consuming. Simply put, a process is a program in execution. This includes the instructions being run, the memory it uses, the resources it needs, files, devices, network, etc., and the management info the operating system uses to control